Hello everybody and welcome back to another Layer by Layer. In last week's tutorial I showed you guys how I put together the new Circuit Playground Express board using EagleCAD and Fusion 360. So in today's tutorial I'm going to wrap this up and make an enclosure using the component that we drew of the Circuit Playground Express. So here it is, here's the board. This is free to download and use in your project, so you can do that. You can download it in many different types of formats. I'll have the link down below. So the first thing we do is create a new document under little file, new, and I already have one saved out. Be sure you save the project first. And then what you can do is import the board into your project by right-clicking on it and going Insert into Current Design. This will bring it in the center of the grid, which is perfect. That's where we want it, so we don't have to move it. I'll just hit OK. And the next thing I'll do is actually make a case component. So I'll right-click on the main assembly here, create new component, and let's go ahead and name it as case, because that's what it will be. And you get a grayed out version of it because now it's activated. So the first thing I'm going to do is actually select the bottom of the component, and it's kind of the face of the component. And then what I'll do is I will create a new sketch. That way Fusion will know where to set the plane, and it'll do a projection of that bottom face of the Circuit Playground Express board. So I'll hide it for now, and what I'll do is I'm going to create a circle in the center of our grid here, and I don't know how big this needs to be yet, so I'm just going to fake a number like 58 and hit enter. The next thing I'm going to do is I'm going to create a wall for the enclosure, so I'll select the outer circle and hit O for offset, and then I'll bring it inwards. And I'll put, actually, I'll just type it in -1 because that's how thick I want the walls to be. So hit OK. And that's kind of it for now. The next thing I'm going to do is I'm actually going to make a user parameter. So I'll bring that window up, and then, well, I already created one, so let me create a new one. And I'm going to call this case diameter. And I'll put in whatever value it was, 58, and hit OK. So now I can extrude this out, and I'll show you why I created a user parameter in a second. So I'm going to bring back the Circuit Playground board, and I'm going to grab these three profiles from the sketch that I drew. And actually, you can see there's a bunch of holes and things. So an easier way to do is, let me hide the Circuit Playground again. And what I'll do is make sure your selection over here is set to window selection. And then I'm going to click on over here on the right and drag to create a marquee window. That way I can select like a bunch of every profile that's in that sketch. And then I'll hit E on my keyboard, and I'm going to extrude it by 1 millimeter down. And it already knows to go down, so that's good, because if we were extruding up, we'd be intersecting into the component. But right now we're creating it down, which is what we want. So hit OK. Now Fusion's going to go ahead and kind of hide that sketch, but we need to bring it back. So I'm going to bring it back. I'll even name it while I'm here. It's called case. I put some capitals there. Whatever. Next thing I'm going to do is I'm going to grab that wall profile that we did, select that, and then hit E on my keyboard to extrude it. And I'm going to extrude it upwards because we kind of want to enclose the Circuit Playground. Now, how tall you want it kind of depends on what you want to do. I want to break out quite a few. I want to expose quite a bit of the sensors and some of the switches. So I don't want it to be too tall. And if I were to encompass the whole case, it would kind of have to be over 10 millimeters or so, just because the JST connector seems to be sort of the biggest thing of the project. So what we're going to do is instead we're going to kind of create cutouts so that these components can kind of poke through the top of the enclosure. So I'm going to make this actually kind of small. I'm going to make this 3 millimeters tall, so hit OK. And now what I'll do is I'm going to create the lid. So to create the lid, I'm actually going to select this top surface of the enclosure, like the lip area. And I'll just go ahead and create I'll go ahead and create a sketch with that selected. In Fusion, Fusion's fine. The next thing I'm going to do is I'm going to select this the inner wall edge, and I'm going to hit O on my keyboard to offset that, and I'm going to bring this in to -1 so that I can have a lip that goes on the inside of the case. So I'll hit OK. And I'm pretty much done with that sketch. I'll name that as the cover because it's going to be the cover of the case. And now I can select those these 3 profiles from the top cover, hit E on my keyboard and extrude it by 1 millimeter. I'll hit OK. And looks like what happened is I forgot to change the operation. So what's awesome about Fusion is you can double click on that extrusion that we did in the timeline and then change the operation to cut, or not cut, but new body. Hit OK, and that creates a new body. So let me bring that open, and let's go ahead and name these now. Call this cover and this one case. Alrighty. So now what I'm going to do is I'm going to rotate underneath it and hide the case, and then I'm going to hide the case sketch, bring up the cover sketch, and then see that little inner wall here that we created, the little inner circle. We're going to extrude that upwards by 2 millimeters. And then I'll hit OK. So now what we have is a lip coming from the cover that will snap into the inside walls of the cover of the case, sorry. And what we can do now is kind of, to get a better look inside of it, we can create a section analysis under inspect. There's a button called section analysis, or I have it already up here. So click on that, and then it'll create a section analysis depending on where you want to set it. So I would open the origins and then select one of these planes, which is fine. And you can rotate it and things, but I'll have it right there. I'll hit OK. And then when you look inside the section analysis, you can see how it kind of works, how it's fitting together. You can see how this wall is has a little bit of clearance, so it doesn't touch the bottom of it, which is fine. We just want to have enough material to kind of be a little bit touching. All right, the next thing we want to do is start creating some cutouts for the top cover, because right now, let me turn the section analysis off. We're intersecting with a bunch of things. You can see the JC is too tall and some of these buttons are a little bit big, so this wouldn't work, right? So we need to make some cutouts. So the first thing I would do is I wrote down some notes of what things we want to expose. And I'm going to type these out, but I already have them typed out, so I'm not going to type them again. So we want to be able to access the USB port. We want to be able to access the JST, the switch, which is like it can be used for on and on or other types of things. The buttons, the 2 buttons on the left and right, the microphone, the buzzer, the reset button, and even the light sensor. So those are some of the things that we want to have access to and get to. I didn't put the NeoPixels because we can print this in like a white case or a translucent case so that the lights can shine through it. So I'll go ahead and get started on making those cutouts. So what I'll do is I'll select the top of this, the top of the cover, and then I'll hit create sketch. So it's really important that we kind of sketch on top of existing geometries and existing faces so that when we update them later, things will just kind of dynamically change. And I'll show you that in just a second here, or after this part, and then we'll kind of adjust the diameter here dynamically. So what I'm going to do is get rid of the cover, just hide it for now. And now that I'm in this sketch here, what I'll do is project in some geometry. So I'll hit P on my keyboard, or you can go up to here where sketches and then hit project, and you can start clicking on things. So I want to expose these 2 buttons, so I'll click on those top surfaces. I want to expose the reset button. The switch, it kind of, you see how this top surface kind of creates an irregular rectangle? I could kind of select the bottom pieces instead and kind of select one line at a time to create that generic rectangle representation of the component. But for this shape here, this is the buzzard, so I can just click on the top face. And I'm not sure where the microphone is yet, so what I'll do is I'll hit stop sketch, and those are projected in there still. So what I'll do is I'll open the component here, the Circuit Playground Express, and I'll look for what I want. So the buzzard, I already got the buzzard. The microphone is over here. So let's project that one in. So I'll go back into that sketch that was, where did that sketch go? Looks like the sketch is on the outside, so that's fine. It just looks like we didn't have the component active. That's okay. We're just gonna go ahead and click on it, open it. We could put it back in the component, but we don't need to right now. So yeah, I already forgot where the thing was. Where did it go? Here's the light sensor. So let's project that in. Hit the project button, bring that in, and then hit OK. Let's see, what else was it? The light sensor's in. We want the temperature sensor is there. I don't want to expose that. And the mic, let's expose the mic. So again, P for project that in, hit OK. All right, the next thing we need to do is create, let's project in the USB port. Those are pretty important. So P on that one. There's another way to do it as well, is you select the surface first and then hit P on your keyboard, and that'll project it in while you're in the edit sketch mode. For this guy here, I'm going to project in some of the lines because there's like a bunch of geometry that I want there. I just want lines, so I'll just select these guys in. There you go. Hit OK. So now if I look at it directly on top, you can see how the projected sketches are the purple lines, and they're exact representations of the components. And if the components ever change for whatever reason, this sketch will update with them because they are projected and they're being referenced by those components. So the next thing we need to do is kind of create some offsets for these cuts, because if we were to cut these out now as they are, they would need a little bit of tolerance in order for it to kind of fit through those components. So I'm going to create some generic rectangles to create offsets. Now you can't really create an offset from a projected sketch. So if I wanted to offset that, if I try it, it works. Wow. I thought it didn't work. Well, guess what? We just learned something new. Maybe it works. So I want to project it outwards by 4 millimeters and hit OK. Wow, it did work. I didn't think it worked before. That's kind of funny. So that saved me a lot of headache, or a lot of work, which I think is great. So what I did though is I double clicked on that, on one of the lines to create, let me try it on this one, double click and you create the whole loop, which is awesome. So I'll offset that one, hit O, put 0.4, maybe copy that into my clipboard because I plan to do that for a lot of things. Double click, O, paste, enter. Double click, did that work? No. Double click. Oh, I see. It doesn't work for it only works for loops and not like, this isn't a full loop for whatever reason. Because when I projected and I didn't project a surface, I projected edges. So in that case, now I can show you how I was originally doing it. It was like use the rectangle tool, which is up here. I used the 2-point rectangle, just kind of create a rectangle over it. And then I used the sketch dimension tool to give it some constraints, saying I want this edge to be a certain distance from that edge, and then I'll put the 0.4. Problem with that is that I have to do it for every edge, every edge. So there's 4 edges, but with it kind of as a workflow, you already know what to do. So I'll hit escape to get out of that tool, double click, O, paste, enter. Great. So it works for most things, but not all of them. And you don't have to use squares. For this light sensor, I'm actually going to do a circle. So I hit C on my keyboard for a circle. And what I'll do is to get to the center of this. Oh, Fusion already knows. Awesome. So I just rolled over, and it kind of gave me a smart guideline. So I'm going to make this like 3 millimeters, like that. And I make a little circle for that, a little circle cutout. I think that's, oh yeah. So now the last things we're going to do is the USB port and of the JST port. So for that, I'm going to create a custom kind of shape. It's going to cut outside over here. It's going to go beyond the edge of the enclosure. And then I'll constrain it to those edges here, like this. 0.4, this one, 0.4, this one, 0.4. All right, so that's it for USB. Now let's do another rectangle for the JST. Some more constraints. That was pretty close. And then the last one here. There we go. Okay, so that's all the cutouts we want to do. The next thing I'm going to do is actually make it easier to select all these profiles, because now you'll see if you wanted to extrude this out, you have to select 2 of these things. So one easy thing to do is to select one of these, one of the edges from the projected sketch and just hit X on your keyboard. And what that'll do is kind of break the loop so that I can select just one profile. And all it's doing, you can always change it back by clicking X again, selecting it, pressing X on your keyboard. But in this case, we probably won't be bringing it back, so this just makes it easier to create. Like that one didn't need it, but this one certainly needs it. So I'll hit X there, X there. It doesn't matter which one you select. So as long as, oh look, we forgot, how could we forget you? We forgot this guy, so I can do an offset here. Double click, O, paste, enter, click on one of these edges, hit X, and I'll even X out the center guy there. So now I just have a straight single profile, and I'll have to do this one too. Cool. And this one, you get an X, you get an X. There we go. I think that's all of them. Yep. So I'll hit stop sketch. Now I will select the things that I want to, looks like I didn't cut one here. Whoops, let's go back in there. And hit X. I really don't want to select multiple, but I'm doing multiples anyway. It's funny. So select this one, this one. Maybe I'm selecting too fast. Nope, just fine. Like that. And then we'll grab these guys. And this guy. Cool. So what I'll do is hide the circuit playground and then bring the cover up. And what I'll do is I'll hit E on my keyboard with those selected, and I will cut. Actually, what I'll do is I'm going to make a dynamic cut on the cover and say I want to extend this to an object from right there. And what I'll have to do is change the chain face. The chain faces need to be on the extended faces so that the extrusion extends out the cut. And we do want the operation to be cut because we're making holes. So I'll hit OK. And now we have some nice cutouts. Looks all cool and crazy looking. All right, so now when I bring back this circuit playground, oh, you know what? I forgot the extrude one. That's fine. Inside of, in the bottom here, I can double click on the feature and just add that by holding down Command on my keyboard. So I hit OK, and it's back. All right, we got it. So let's bring back the circuit playground again, kind of make sure that we got all of our points, and I believe we did. Cool. So the next thing I'm going to do is bring back the case, and I need to kind of create some cutouts here because it looks, especially for the USB port, you can see that the lip is covering it right now. The wall of the case. So what we need to do is bring back our sketch here that was making cuts, and actually I'm going to do something a little bit special with the USB port. I'll show you what I'm going to do. So I'm going to go back in there, and I'm going to create a line using the line tool up here, sketch, line, or L on your keyboard. And I'm going to cut it like right about here, creating a line, and then I'm going to use the sketch dimension tool to give it a constraint. I want to be 1 millimeter away from it. Hit OK. So now I can do is select that little thing here that I made. It kind of intersected and created this little rectangle shape. So I hit E on my keyboard, and I'll start extruding this down until I reach, I think 2.5 millimeters is fine. So when I hit enter, you can see now I have room. Actually, I want to cut all the way down. Let's cut all the way down. So I'll change the extent from distance to object, and then click on the bottom, hit OK. That way, when we put a USB cable in here, it has room to reach it. And the next thing I'll do is, actually, this is probably a good opportunity to update the diameter of the case. So check this out. Looks like the hole here doesn't look correct. So what I think happened is inside the sketch we forgot to put a what do we call it? A construction line for that. So whoops, that was a problem. Hit OK, and then go back into the cut, the first cut, and then select that back in there. Sorry, that was kind of weird. All right, look, what I want to show you is I'm gonna hide the case for a second, And you can see now that it's really the inner lip that we need to worry about if we're gonna decrease the overall diameter of the case. We need to keep our eye on this and make sure that this wall doesn't touch the edge of the PCB. So we want to have a little bit of clearance there. So what I'm going to do is I'm going to bring back our change parameters. I'm going to drop this down to 57, 56. And what you'll see is that it's supposed to change the diameter, but it's not changing. So I'm going to go back into this first case. And you see where it says, oh, obviously I didn't apply it. See how it says 58? I'm going to double click on that and change this to case diameter. I just hit D on my keyboard and it kind of knows I'm looking for diameter. So I'll hit enter on that. And you'll see that it changed to FX56. That's basically saying that's a function and the dynamic value is 56. So when I hit stop sketch, you probably can't tell that the thing has changed, but it certainly has. So I'm going to hide the sketch again and bring back the bottom here so I can see the inner lip. And you can see that it's now closer to it. So what it was before was 58. So let me change that back to 58 just to give you a look at it. And you can see how it updated everything. It updated all two pieces, and the cutouts stayed the same. So let me do something drastic like 70. Makes it really, really big. And you can see some of the cutouts didn't go with it because they're a certain size. But that's okay. I'm going to bring this back to 56. Or maybe it's 57. I think 56 is actually fine. So we want to have a teeny bit of clearance here between the two edges, which is fine. So I'll hit OK. I don't know, that's just a quick little thing that I wanted to show you guys. Like I wasn't too sure how big the diameter should be. So by being able to use a parameter, I can dynamically set it without having to change too much as long as you apply it, right? I didn't apply it first, so that's why I had to go in there. So the last things I'm going to do is actually make it easier to align these two pieces when we snap them together. So to do that, what I'm going to do is I'm actually going to make some nubs, extrude off of the bottom of the enclosure. Let me hide this sketch here. This surface here, see how that's the bottom of the case? I want these little nubs to poke through some of these holes, some of these the pinouts. So what I'll do is with it selected, I'm going to create a new sketch. And I'm going to project in a couple of these circles. So P on my keyboard, I want this one, and then those two on the opposite side of the board. So these guys over here next to the USB port. So these two. And that's what I want to do, just those two. So now what I can do is, I'll hide the circuit playground for a second. I can select these guys by holding down Shift, the profiles. I'm just selecting the profiles, and then I'll hit E on my keyboard to extrude. I'm going to extrude these out to about 2.8 millimeters. And I want the operation to be join, so I'll hit OK. Now, the next thing I'm going to do is actually going to click on one of the nubs and hit Q on my keyboard to make it offset. Make sure it's set to new offset, and then I'll select the rest of the four here. And then I'll put an offset of -0.2, essentially making it kind of smaller than the hole, because when you're 3D printing these actually tend to expand a little bit. Next thing I'm going to do is select the four of these top edges on the nubs and hit the S key to bring up the model toolbox and just type in cham for chamfer, hit enter, and then I'll put a value of 0.5, half of a millimeter. And now I have these nice little pins that can go inside of the pins. These little nubs that can go inside the pins, hole pins. So now you got these little mounting points that will ensure that our board is correct. Our board is actually aligned properly. I'm looking at this JST thinking I need to make a cutout for that, because yep, I definitely need to make a cutout there. So that's easy enough. We can come into what was it, sketch 6, and kind of make a click on that, extrude this down, and it'll turn into a cut automatically, which is nice. And 2.5 is perfect, so hit OK. So now you can see I have a little bit of cut there on the wall so that the JST connector can go inside the JST port. Excellent. Actually, the next thing I'm going to do now is kind of do this similar thing I just did to the bottom, but for the top, but on different pins. So I will hide the case, bring up the cover, and then select the inside surface of the cover, and then I'll hit I'll create a sketch on top of it. And then instead of obviously selecting these, I'm going to select I'm going to hit P on my keyboard to project in just 2 pins, one from the far left and one from the far right, like that. And I'll hide the component, hit OK, extrude these out by 2.8 of a millimeter, and then I'll again create an offset on these nubs of -0.2, like that. And then again, I'll create some more chamfers, using the model sketch toolbox, or the model toolbox, cham 0.5. All right. So then I can see that those will go inside nicely as well. So now if I bring back both of the cases, you can see what we got going on here. There's a little bit of fine tuning we can still do. What I'll do is, let me see what the edge distance is here. The length is 1.533. So what I'll do is I'll select these sharp corners here, and I hit the wrong key command, so I'll select them again. Hit S, cham, enter, and it was 1.533, I believe. Hit enter. So all that did was just kind of create this nice chamfer to round out, not round out, but to kind of soften up these corners here. Opens it up a bit, and I'll do that here too. So what is this? Is just one. So select these, and then cham, just one. All right, that looks good. And then again, we can use this section analysis to kind of poke through and make sure that we have proper clearances and things, and we do. So I think that's good. Well, we can 3D print this out now. And obviously what we could do is we could expose some of the pinouts here, or yeah, some of the pins from, or all of the pins rather, for the Circuit Playground Express board. But that could create some different issues. One solution I have is to use to kind of dual extrude it and make some custom pads printed in conductive PLA filament, so that way your enclosure can kind of use tape, copper tape, or bare conductive paint, and then you can pop in your Circuit Playground in and out of this case and kind of make it non-destructive in a way a little bit, so you can reuse the Circuit Playground and put it into certain conductive projects. So that'd be kind of neat. But there's lots of different things you could do with it. This is just a really quick way to make a super simple enclosure that still gives you access to some of the buttons and some of the sensors. So it's pretty cool. Let me know what you guys think. I'll have the file again for this enclosure as a download link in the link below. You can download Fusion as well, so check that out if you like. Or you could download the Fusion archive as a step file and use it in SolidWorks or OpenCAD, Onshape, all those fine choices. But that's going to be it for this tutorial. Thank you guys so much for watching, and if you have any tips or suggestions, go ahead and leave them in the comments below, and go ahead and leave what you're working on. I'd love to share it on 3D Thursday on the blog. Yeah, Circuit Playground is still in the works, and you guys will know about it if you follow Adafruit on Twitter and all the other social channels, and even the blog. You'll know when it comes out. That's it for me. I'll see you guys in the next one.